Let us consider the structure of cubic zinc sulphide, also known as zinc blende. In this structure, we have the cation zinc double plus 2 plus, which has a ratio which has a radius of 0.883 angstrom, anion, it's sulphide anion with a radius of 1.74 angstrom. If we take the radius ratio, we get a value of 0.48. This value comes between 0.414 and 0.732. So, this implies an octahedral coordination of 6 sulphide ions around a zinc cation. But in this case, we are unfortunate, this prediction turns out to be wrong. This is not the right prediction, and the actual structure has a tetrahedral coordination of 4 sulphide ions around a zinc cation. So, this example, this counter example shows that radius ratio is actually a rule of thumb. It is not a some hard and fast rule which cannot be violated. In some cases, like in case of the zinc sulphide, we do not get a structure which is predicted by the radius ratio. Instead, we get a tetrahedral coordination of 4 sulphur around a zinc. What kind of a structure is this? So, let us look at this. This structure can be related to the diamond cubic structure which we have studied before. So, the diamond cubic structure is an FCC lattice, but has 2 atom motif. So, the carbon atoms are at the FCC lattice points, as I have already shown, at the corners and face centers, but then there are 4 carbon atoms inside the unit cell which are sitting on one each on the body diagonals. So, there is a carbon atom here on this body diagonal, and there is another carbon atom here on this body diagonal. On 2 body diagonals, the carbon atoms are 1/4 up from the bottom. On the other 2 body diagonals, the carbon atoms are 3/4 up from the bottom. So, these 4 inside carbon atoms, although all of them are carbon, but let me shade the body diagonal ones just to emphasize that they are located on the body diagonal. And this is how then, but both of them are carbon. So, in diamond cubic crystal, diamond is anyway element, all atoms are of the same type, but some are located on the face centered cubic site and others on these body diagonals. The cubic zinc sulphide structure can be related to this. So, the sulphide ions can now be made to sit on each of these face centered cubic site. So, I am placing the red sulphide ions first on the corners of the cube, and then on the face centers, the top and bottom face centers, the left and right face centers, and front and back face centers. So, this completes the locations of the sulphide ions. This is sulphide ions. The zinc ions are located exactly on the body diagonal, just like in the case of diamond. So, on 2 body diagonals, they are 1/4 up from the bottom. In other 2 body diagonals, they are 3/4 up from the bottom. So, the structure again is an FCC lattice, and the motif is again of 2 atoms. only difference is that now these two atoms are not of the same element, they are of different element. I am writing atom, but when if you wish you can write it as ion. So, the sulphide ion is sitting at the lattice point, whereas the zinc ions now are located at the quarter site, 1/4, 1/4, 1/4. So, this is the cubic zinc sulphide crystal. Again, these two structures should be considered as different crystal structure despite their similarity. We will have diamond cubic crystal only if both the atoms are same. We will have a zinc sulphide structure if the two atoms are of different type, the body diagonal ones and the corner and face center ones are different. So, like other structures, the cubic zinc sulphide also is a prototype structure, and many other compounds, many other equiatomic compound form cubic zinc sulphide structure. So, they are zinc oxide, beryllium oxide, gallium arsenide, silicon carbide, boron nitride, among many others.